ओके, मेरी आवाज आ रही है? कैन यू हियर मी? हाँ,
यस सर।
तो कैमरा ऑन करो सभी जल्दी से। कैमरा ऑन। चलो, हम कर रहे हैं वो प्रिलिमिनरीज फॉर दिस Banach-Stone थ्योरम, उससे रिलेटेड कुछ रिजल्ट्स। तो लेकिन कल का जो हमने थ्योरम किया था उसमें एक चीज हमने, मतलब क्योंकि वो लंबा चौड़ा था, मैंने ऐसे ही वो क्या बोलते हैं सपोर्ट ऑफ ए मेजर को ठीक से मतलब बताया मैंने कि जहां पे वो मेजर वैनिश नहीं होता, बट दैट्स नॉट मतलब द एग्जैक्ट डेफिनेशन। सो इन ऑर्डर टू क्लियर दैट, तो मैं यहाँ पे थोड़ा मेजर का जो सपोर्ट है, हाउ इज इट डिफाइंड, तो उसके दो तरीके हैं। You know, if mu is a measure on a Borel measurable space, and then mu is a measure. If mu is a measure on a topological space, that means it is a collection of Borel sets B. Then if mu is a measure on B, that means it's a function from here to in this interval. We say support of mu is set of all points inside X such that every measure such that every open set, let me call it n sub x, containing x has positive measure. और भी definition है, but this is equivalent. तो इसका क्लोजर, इस सेट का जो क्लोजर है वो सपोर्ट कहलाता है। मैंने कहा था जब फंक्शन वैनिश नहीं होती, जहां मेजर वैनिश नहीं होता, इट इज इक्विवेलेंट टू दैट, बट दिस इज मोर प्रॉपर डेफिनेशन। Now in the case of complex measure, a measure that means a positive measure, हमारा जो measure था it was a complex valued measure, क्योंकि हमने एक जगह इसको इस्तेमाल किया। तो complex valued measure mu can always be written as where m1 plus m2 plus, I should write minus m2 plus iota times mu3 minus mu4, where mu1 is a measure, mu1 चलो mu i's जो हैं are positive measures or simply measures, और support of mu जो होता है of this complex measure, support of mu जो होगा, जिसको हम कभी-कभी लिखते हैं SPE mu, is actually the union of the supports, of mu I runs from 1, 2, 3, 4. Then you can always break a complex measure into measures like this, or into positive measures like this. So then support of that complex measure would be union of these measures, and union of measure or the positive measure is defined by this, that every neighborhood which contains a point of support, uska measure positive hoga, strictly positive hoga. Also, this the total variation mu, मतलब ये जो ये measure है, it is always equal to mu1 plus mu2 plus mu3 plus mu4. So this is the measure total variation. तो उसका मतलब ये हुआ, it implies that if U is an open set containing a point of support of mu, this complex measure. So at least one of these measures of the sets mu1, mu2, mu3, mu4 would be non-zero, which means then this would be non-zero. Or हमें use मतलब positive, sorry. So it would imply that mu I of u is strictly positive for at least one I, which would imply that जो हमने यूज किया एक जगह पे मतलब दो जगह पे मतलब दिस इज द रीजन क्योंकि वहां मैंने मेजर को जल्दी में बता दिया लेकिन क्योंकि वो बड़ा सा थ्योरम था इसलिए मेरा ध्यान नहीं हुआ इसको बंद करो ना या ये दरवाजा बंद करो हेलो हेलो इधर इसको बंद करो आवाज आ रही है ना इसलिए ओके सो लेट्स मूव फर्दर इन आवर प्रूफ ऑफ Banach-Stone थ्योरम ये मैं उसके लिए क्लियर करना चाहता था मुझे लगा कि मैंने वहां मेजर ठीक से डिफाइन नहीं किया दैट वाज द रीजन एक्चुअली वो चूंकि काफी बड़ा था वो पॉसिबल भी नहीं था कि वहां पे वो हम इतना डिटेल में जाएं क्योंकि वो उसमें क्या एक दो क्लासेस हमारी हो गई उसके प्रूफ में ही सो वी वुड कंटिन्यू विद आवर दिस क्या बोलते हैं दिस Banach-Stone थ्योरम तो एक और रिजल्ट हमें करना पड़ेगा इसके लिए वो ये है that if x and y are normal linear spaces theorem if x and y are normal linear spaces and t from x to y is an isometric isomorphism then the conjugate t star which is a map from y star to x star is also an isometric isometric isomorphism and furthermore T star का जो inverse है क्योंकि अगर ये isometric isomorphism है तो in particular it is a bijection तो T star inverse is the same as T inverse का star so let's do the proof and just to remind you T is a bounded linear map from X to Y and in our case we are assuming that it's an isometric isomorphism and it's more than that it's a bijection that's continuous that's an isometric then T star, as you know, from Y star to X star is defined as T star at F is equal to F composition T or जैसा कि हम कभी-कभी लिखते थे T star at Y star is equal to Y star composition T. मतलब F because this F belongs to Y star तो इसको small Y star से represent कर सकते हैं. Not only that, now if we think of now, because T inverse exists, so T inverse exists, let's call this S. Now, this would be a map from Y to X, right? Because T is a map from X to Y, so this is again a 1-1 map. This, in fact, would be a linear map automatically. And S star then would be a map from X star to Y star. So let's do that. So let me write here. Let me denote S to be T inverse because it exists, because by my assumption T is an isometric isomorphism, in particular a bijection. And let S star and T star be the conjugates of S and T respectively. No, S, I will say S and T respectively. So we have to remember now S is a function from y to x, and S star is a function from y star, the x star to y star, defined by S star at x star is equal to x star composition S. तो जैसे कि वो डिफाइंड था y स्टार कंपोजिशन t, यहाँ पे s x स्टार कंपोजिशन s, मतलब इट्स वेल डिफाइंड, हम कई बार इसको यूज कर चुके हैं, everything is very clear. Now let f belong to s star at f, let this belong to x star and x belong to x, then t star applied to s star at f. Now remember that t star is a map from y star to x star, right? So if I say s star at f belongs to y star, right? And then t star can apply on it. So t star at s star at f would belong to x star. So t star at s star at f belongs to x star. It means that it's a map from x to k. So I can apply it at x. Then this should be equal to, now look at this. S star at f kahan belong karta hai? S star at f belongs to y star. Now S star at f jo hai, S star at f belongs to y star. So it is some kind of a small y star. And I have got t star y star applied to x. So it should be y star composition t. Now maine kya galat kiya? Should be, how did we define t star at y star? Y star composition t. So it should be y star composition t applied to x. So y star की जगह यहाँ कौन है? Y star की जगह है S star f. So it should be S star f applied to t of x. Right. Applied to t, composed with x. But again, this is S star f composition t. Should I write it like this? Now look at it. S star at f किसके बराबर है? S star at f is equal to y, and S star at x star is x star composition S. So यहाँ पे मैं सीधे लिख सकता हूँ, this is f composition S, composition t of x. So that is actually, इसको मैं ऐसे लिखता हूँ because composition is associative. So मैं ऐसे लिख सकता हूँ f composition is composition t applied to x, which is same thing as f of x. Why? Because S is equal to t inverse. So S composition t जो है वो होगा identity. तो इसका मतलब क्या होगा? Now this is true for all x belonging to x. So which implies that t star composition S star applied to f is f for all f belonging to x star. इसका मतलब क्या हुआ? It means that t star composition S star is identity on x star. है ना? On the other hand, अगर मैं इसी तरह से evaluate करूं for all g belonging to y star and y belonging to y, it would imply that, what does it imply? I take S star, t star applied to g, applied to y, you would get, by the same process, you will get actually, you know, खुद करोगे by looking at these maps, how they are defined. So this is g of y for all y belonging to y, which implies that S star composition t star applied to g is equal to g for all g belonging to y star, which implies that S star composition t star is actually equal to identity on y star. So what does that mean? So पहले हमने लिया था, I've got a map t star from y star to x star, and I'm being told that S star is a map from X star to Y star such that T star composition S star is equal to identity on X star and S star composition T star is equal to identity on Y star. It implies that nothing but that T star ka inverse is equal to S star. But S star is actually S inverse, which is actually T inverse का conjugate. तो ये पहला हिस्सा तो प्रूव हो गया कि ये इसका इन्वर्स है, यानी T conjugate का इन्वर्स है T inverse का conjugate, right? So if it exists, now we just prove that T is an isometry, that means it will exist. Now to prove that, so whenever मैं कह सकता हूँ ये एग्जिस्ट करेगा क्योंकि टी इनवर्स एग्जिस्ट करता है ना, इसका मतलब टी स्टार इनवर्स भी एग्जिस्ट करेगा बिकॉज इफ इट इज इक्वल टू दिस, so it means because this exists, so its conjugate exists. Okay, so now the only thing, now या सीधे में लिख देता हूँ, since T star is linear in any case, अगर मुझे दिखाना है आइसोमेट्रिक आइसोमॉर्फिज्म है तो T is linear because it is by definition linear. So therefore the only thing that remains to be proven, the only thing that remains to be proved is that T star is an isometry. Isometry, right? So uske liye, now let F belong to Y star, and then for X belonging to X, you should have T star at F, of course, that belongs to X star, so it applies on X, is equal to, by definition, F composition T of X, which is equal to F of T of X, but this is, as we know, bounded linear function of F, so it is less than equal to norm of T into norm of X. So since T is an isometry, T is an isometry, norm of T is equal to 1. ये मैं तुम पे छोड़ देता हूँ कि तुम खुद करोगे, वैसे ये इजी है. क्यों? norm of T जो है, that is defined to be supremum norm of X is equal to 1 of norm of T of X. Again, because it's an isometry, norm of Tx is equal to norm of T, norm of X, so it is actually supremum over norm of X is equal to 1. Say 1 upper method norm of X, which is equal to 1. That's obvious. So since T is an isometry, norm of T is equal to 1. It implies that norm of T star at F, which is equal to supremum over norm X is equal to 1, norm of T star F applied to X is less than equal to, क्योंकि हमें पता है norm of T is 1, so this is less than equal to norm of, actually चलो मैं ऐसे ही कर देता हूँ, supremum norm X is equal to 1, norm of T star norm of F, oh sorry, यहाँ norm of T होना चाहिए पहले, should be norm of F, norm of T जो कि 1 है, into norm of X जो कि 1 है, that is हमें मिलना चाहिए norm of T star at F is less than equal to norm of F. Finally, Now, by the definition of the supremum, now let epsilon be positive, then we can find y belonging to y with norm of y equal to 1 such that norm of f minus epsilon is strictly less than modulus of f of y. Well, that's just the definition of supremum, because norm of f is just the supremum over norm y equal to 1 mod of fy, and we are assuming that f belongs to y star, of course. Okay? So this would always be true. Now अब इसमें थोड़ा सा मैं यूज करेंगे फिर से, since T is an isometric isomorphism जो भी है, तो isometry in particular, isometric क्या लिख रहा हूँ मैं, isomorphism, then for every y belonging to y, there exists a unique x belonging to x such that x is equal to T inverse of y. So which implies that, so therefore norm of x जो है वो मैं लिख सकता हूँ, because T is an isometry, is equal to norm of Tx. But this would be the same as, because x can be written as T inverse of y. So it would be T into T inverse of y, T of inverse of y, which is equal to, because T inverse khatam, so it is norm of y, that's equal to 1. So, and norm of f minus epsilon is strictly less than fy, जो कि हमने इससे पहले किया था. But f can be, this can be written as f of T of x, because I'm assuming that y is equal to, the x is equal to T inverse of y, or y is equal to T of x, एक ही बात है. But this is the same thing as T star f of x, that is the definition of the conjugate, which would be of course less than equal to supremum over supremum of these numbers mod of T star f of x such that x belongs to x and norm of x जो है मतलब इसके सुप्रीमम से लेस ही होगा. Reason being what, मैं अभी लिखता हूँ यहाँ पे, norm of x is less than equal to 1, that is equal to norm of T star of f. Now we have to think of this as better ये है modulus of T star. तो यहाँ पे चलो मैं एक बात, just to make it a little clearer, norm of T star of f applied to x, right, इस तरह से. So ये होगा less than equal to this thing, actually ये सीधे लिख सकता था, because norm of x is equal to 1. So therefore this is less than equal to supremum, तो norm of x चूंकि 1 है तो ये सेट में आ जाएगा, so supremum से less होगा, which is equal to norm of T star of f. Now which implies that norm of f is less than norm of T star of f plus epsilon for any epsilon positive. So it should imply that, और चूंकि ये बड़ा है, ये चूंकि हम ऑलरेडी प्रूव कर चुके हैं, combined with this, let's call this star, combined with star, it implies, चलो मैं ऐसे लिखता हूँ, for norm of f is less than equal to norm of T star of f, hence T star of f is equal to norm of f by star, which implies of course T star is an isometry. Is an isometry, of course isometry linear तो होगा ही, तो वो तो by definition ही linear है, so it's a bounded linear operator in fact. तो हमने दिखाया ये isometry है and we are done. So ये एक और चीज हो गई, जो हम थोड़ा प्रिपरेशन कर रहे हैं। और आपने क्या किया लास्ट टाइम हमने किया था ये सेट ऑफ एक्सट्रीम पॉइंट्स x is compact, set of extreme points of the unit ball of mx, where mx are the complex valued Borel measures on this space x. This was of this type, alpha del x, so that modulus of alpha is equal to 1, x belongs to x, and the extreme points of the probability measures is just del x, so that x belongs to x. So ये चीजें हमने की और हमें क्या करना चाहिए, let's see और क्या क्या हमें करना है। नेक्स्ट है हमारा, so if you have x star, you already know that x star जो है it has a weak topology, it has a norm topology, and it's a weak star topology, which is a very important topology basically on x star. So just to remind, weak star topology on x star is the topology generated by x that's equal to g of x contained in x double star on x. और so usually हम कहते हैं that is it is generated by open sets या by sets of the type. अब हम बहुत सारे उसके लिए लेते थे, मैंने x cap लिया था such that x cap of x star is equal to x star at x, right? कभी कभी ऐसे ही लिख देते हैं x double star at x star is equal to x star at x, मतलब फंक्शन की डेफिनेशन जो है वो सेम है। और कभी कभी f sub x of f is equal to f at x for all f belonging to x star। तो ये सभी नोटेशंस यूज होती है, तो हम ये वाली नोटेशन लेंगे, यानी ये ऐसी टोपोलॉजी है कि it is the smallest topology under which these fx's are continuous. Of course, it is smaller than norm topology because under norm topology, these functionals are obviously continuous. So it is generated by, what does that mean? अगर मुझे इनको continuous रखना है, मुझे ये ensure करना है मेरी जो topology हो उसमें कम से कम inverse images of open sets under these maps मतलब lie करें, यानी it should be generated by f sub inverse of u, because f sub x is a function because it belongs to x double star x star to k, which is usually the set of complex numbers or real numbers. So अगर ये sets such that u is a subset of k and u is open, and x is an element of x, which is defined this way. अगर ये collection को मैं as a sub basis लूँ, inside, of course it's inside x star, but these are contained inside x star. So अगर मैं इसको sub basis बना के एक टोपोलॉजी बनाता हूँ, यानी मैं इसके सारे फाइनाइट इंटरसेक्शंस लूंगा इस कलेक्शन के, फिर उसके सारे पॉसिबल यूनियंस लूंगा, तो इट वुड बी अ टोपोलॉजी under which would contain at least these types of sets. So it means it would be the smallest topology possible, under which all these fx's are continuous, and it would be by definition the weak star topology. अब मैं एक ही चीज यहाँ पे करूंगा, मैं fx नहीं लिखूंगा क्योंकि f मैं किसी और मैप के लिए कर रहा हूँ यूज, सो तुम्हें परेशान, मैं इसको phi sub x से डिनोट करूंगा। प्रॉब्लम कुछ नहीं है, एक्चुअली है कि हाउ डज द मैप एक्ट, तो मेरे हिसाब से f sub x is a map from x dot k, जब मैंने डिफाइन किया, where f sub x at f is equal to f of x, तो f sub x थोड़ी सी, तो ये सब बेसिस ट्रीट करूंगा मैं इन सेट्स को, सो दैट वुड बी माय वीक स्टार टोपोलॉजी। ठीक है, नाउ वीक स्टार टोपोलॉजी इज not meterizable unless you restrict it to a bounded set. So therefore when we talk of convergence, so the meterizable अगर नहीं है तो तो अब चूंकि मेट्रिक स्पेस में एक एडवांटेज होता है कि you can define the continuity in terms of convergence of sequences. But in terms of an arbitrary topology, you have to define the topology. You can define it in terms of convergence of the nets. So what we write, so we say, okay, let एक definition की तरह इसको लिखते हैं. Now let X be a normed linear space and consider the X star under weak star topology. और कभी-कभी अगर तुम्हें याद हो हम इसको लिखते थे X star sigma X star X. Now if I take a net, and in case you remember what's the net, so alpha belongs to delta, where delta could be any index set, any partially ordered set, in fact. Be a net in X star, then X alpha star to have as a this net is weak star convergent to X star belonging to X star if and only if limit over alpha, but this is not that limit, this is the limit of a net X star at alpha, oh, sorry, X, get it wrong. X star alpha at X is equal to X star at X for all X belonging to X. यानी हम कह रहे हैं, then this net of numbers X star, this is now a net of numbers, must converge to X star at X for all X belonging to X. तो हम इसको कहेंगे it is convergent within the weak star topology. ठीक है, मतलब this is the definition of convergence under weak star topology. Actually तुमने इसको देखा है weak star convergence में, लेकिन वहाँ पे that was weak star convergence for sequences. But sequences are not sufficient for describing continuity in weak star topology because it's not metrizable. In metric space it is. So in case you don't remember the net, so you've got nothing but net is a map, just like a sequence is a map from the sequence xn, should I write? You know, sequence is a map, you know, from set of natural numbers to the field K, जहाँ पर भी आप sequence चाहते हो, it could be inside X, normal linear space. If it's a sequence of real numbers, तो यहाँ R आएगा. If it's a sequence of complex numbers, तो यहाँ C का है. If it's a sequence of vectors, तो यहाँ वो vectors आएगा. लेकिन domain होगी set of natural numbers. So, but if you take here any partially ordered set, let me call it delta, 2x R C, so it becomes, you know, it becomes a net in of vectors, a net of real numbers, a net of complex numbers. So of course natural numbers is also a partially ordered set, so every sequence is a net, but net is a more general concept, right? So when do we say a net? Suppose in a topological space, in general topological space, we say XL alpha converges to X as a net if and only if for every let's say for every unit closed, there exists a beta belonging to delta, ये जो मेरा index set है, such that okay, पहले जरा मैं इसको ठीक से लिखता हूँ. Okay, X alpha converges to X as a net if for any open set U of X there exists a beta belonging to this delta such that X alpha belongs to U for all beta greater than equal to alpha, because इसमें partial ordering तो है ही, so I can think of beta being greater than equal to alpha. So it very much corresponds, बिल्कुल यही definition अगर तुम यहाँ natural numbers पे लगाओगे, it would satisfy the convergence of a sequence. So it's a more general idea. So okay, so that was about nets. So another definition जो हम use करने वाले हैं, so if you have x and y be normal linear spaces, and we consider x star under weak star topology and y star under its weak star topology. So and let ऐसे लिखेंगे, so ऐसे लिखता हूँ, for x star belonging to this capital X star, ऐसे कैसे लिखूंगा, तो मैं दिखाना चाहता हूँ the continuity between these two in terms of nets. तो कैसे करेंगे? So let T be a map from X star to Y star, then T is continuous. I should write actually weak star continuous. Continuous when we consider the weak star topologies of X star and Y star. Continuous at X star belonging to this capital X star if X alpha star, if a net X star alpha converging to X star in X star implies that T of X star at alpha converges to T, this net converges to T of X star. So of course इसका मतलब है अगर हम नेट्स कन्वर्ट करेंगे तो यहाँ पर भी, तो चूंकि वीक स्टार टोपोलॉजी है, तो यहाँ जब मैं कन्वर्जेंस की बात कर रहा हूँ तो इट वुड इम्प्लाई वीक स्टार, और यहाँ पर भी ये कन्वर्जेंस मतलब है वीक स्टार, कन्वर्जेंस ऑफ नेट्स इन वीक स्टार टर्म्स, एंड व्हिच वुड इम्प्लाई दिस थिंग. वीक स्टार कन्वर्जेंस का मतलब जब मैं ये कह रहा हूँ इसको कन्वर्ज करेगा, तो उसका मतलब x star at alpha at x would converge to x star at x for all x belonging to x. Same here. And t x star of x, जहाँ पर भी sort of belong करते हैं net, it's inside y, so it means tx star at y would converge to tx star at y for all y belonging to y. So जब मैं कह रहा हूँ weak star convergence. So अब इसमें 1 मिनट और है, तो जो हम, तो इसलिए मैं इसको काट देता हूँ क्योंकि मुझे फिर से रिपीट करना पड़ेगा. एंड यू जॉइन अगेन. कितने आए हैं आज? 23.